The JWST, or James Webb Space Telescope, was launched on December 25, 2021. With its 21.3-foot primary mirror, this telescope will allow us to see farther into the universe than ever before. In addition to that, it will allow us to see infrared, the area of the electromagnetic spectrum that emits wavelengths longer than visible light. Its main purpose is to study the details of planets around other stars, also known as exoplanets. It's planned to sample populations of planets of various masses and densities in different environments. So, what does the JWST project mean for astronomers? Well, alongside the previously mentioned goals, they get to learn more about how early galaxies are formed and how they grew using the infrared cameras such as MIRI or Mid-Infrared Instrument. They can also learn more about the chemical compositions of other planets, possibly leading to detecting life and habitability. This telescope contains something called an Integrated Science Instrument Module, or ISIM. The ISIM can be broken down into different instruments comprised of unique lenses, masks, filters, and other customized equipment. Before it can capture and share the amazing photos, the JWST had to be aligned. To date, it has 7 alignments, with the most recent one taking 3 months to complete. The image quality is diffraction limited, so the detail in images are limited to the physical size of the telescope. Fortunately, the optical performance continues to be better than the engineering team's most optimistic predictions. In order to capture images, the telescope must undergo several steps. These consist of a segment image identification, which align the telescope relative to the spacecraft using star trackers. Next is the segment alignment, where most large positioning errors of the mirror segments are corrected. Then we have image stacking, where individual segments are stacked such that they are precisely at the center of the field to produce one image. Fourth is coarse phasing, which ensures that all the segments from the previous step are aligned with extreme accuracy. Next is fine phasing. This operation is done over the telescope's lifespan, as they measure and correct the remaining alignment errors using a defocusing method. After that, the telescope must be aligned over the rest of the instrumental fields, since at this point, the alignment was in the NIRCam field of view. The last step is the iterate alignment for the final correction. At this point, the goal is to remove any small residual positioning errors. Final checks are made on the image quality across all the instruments, and once verified, the process is complete. After all the hard work, July 12, 2022, the James Webb Space Telescope released the first set of images to share with the world. This is the Southern Ring Nebula, 2,000 light-years away, and it consists of clouds and gas particles from red giants who reached the end of their lives. Each of these layers actually represents a different shell of gas that was thrown off the red giant. This is another image of the same thing, just with a different camera called the MIRI. This camera is able to capture longer wavelengths, allowing us to see things that you can't see in the previous image. This is the Carina Nebula, which is about 7,500 light-years away. This nebula is actively gathering together to form new stars. This image is helping astronomers gain insight about how stars form. Some astronomers like to call this the cosmic cliffs. Similar to the previous image, this is the same location, but shot with the MIRI camera. So here, we can look through what's behind the clouds of dust. Now beyond our galaxy, 300 million light-years away, is Stephan's Quintet. It consists of 4 galaxies close to one another. The bright spot at the bottom circle is actually a different galaxy that's only 40 million light-years away. It just happened to squeeze in the picture. 2 of them are currently merging, and it's believed that all 4 of them will emerge eventually. This is actually a composite of over 1,000 images. If you zoom in, you can go really close and see a lot of detail. And here, we see the same image, but using the MIRI camera. And notice the really bright thing in the top right? That's a supermassive black hole, which is 24 million times the mass of our Sun. The last image is a galaxy cluster. It's 4.6 billion light-years away, and it captures such a large area, you can even see a dip in space. See how this light is bent? The light from distant galaxies is magnified. We can see this due to gravitational lensing, and it's enabled us to see stuff That is over 4.6 billion light years away. The JWST is contributing so much to astronomical discoveries, and we can expect more pictures to come in the future as the mission to discover the infrared universe marches on.